Welcome to the module on Introduction to Amazon Web Services. To begin. Hi, I was comparing few options of cloud computing services for my business requirements. Provide overview of any one public cloud service.
Don't worry, I will be taking you through a knowledge bite on Amazon Web Services, AWS, where we will learn all about it. After going through this knowledge bite, you will be able to explain what is meant by AWS. Describe various service category provided by AWS. Describe the commonly used services provided by AWS. Amazon Web Services is a platform that offers flexible, reliable, scalable, easy-to-use, and cost-effective cloud computing solutions. AWS is a comprehensive computing platform offered by Amazon. The platform offers infrastructure as a service, platform as a service, and packaged software as a service offerings. AWS is one of the public cloud service provider, offering over 200 fully featured services from data centers positioned globally. AWS offers scalable solutions for compute, storage, databases, analytics, and more. With AWS, leverage the latest technologies to experiment and innovate more quickly. Amazon Web Services offers a wide range of different business purpose, global cloud-based products. The products include storage, databases, analytics, networking, mobile development tools, enterprise applications, with a pay-as-you-go pricing model. The complete range of products are as follows: analytics, application integration, AR and VR, blockchain, business applications, compute, containers, database, developer tools, end-user computing, front-end web and mobile, game technologies, Internet of Things, machine learning, management and governance, media services, networking and content delivery, quantum technologies, robotics, satellite, security, identity and compliance, serverless, storage. Plenty of services are there, but they are grouped under separate features like compute, security management tools, storage, messaging, database migration, networking, analytics, and a few more things also there. But these are the primary features which all the important service is going to do its operation in AWS. As discussed, all the features of services are not going to play its role. It is based upon the requirement of developer who is design and use their exact features. Few of the critical services offered by AWS are compute service, storage service, database service, management tools, migration services, content delivery network services, security and identity, compliance services, and messaging services. Learn more about each service one by one. AWS Compute Service. The compute domain includes services related to compute workloads. It includes the following services: instances, virtual machines, containers, serverless agents, hybrid. EC2 Compute Cloud. EC2 is a virtual machine in the cloud, on which you have REST-level control. You can run this cloud server whenever you want. EC2 is the most used service offered by AWS. It gives you the ability to configure and deploy your very own server for your product or application, giving you complete control of the instance of your virtual machine. On using this service, you get an option to choose what type of operating system would you like to use, like Amazon Linux, Ubuntu Server, CentOS, Windows Server, etc. Light Sail. This cloud computing tool automatically deploys and manages the computer storage and networking capabilities required to run your applications. Elastic Beanstalk. The tool offers automated deployment and provisioning of resources, like a highly scalable production website. EKS Elastic Container Service for Kubernetes. The tool allows you to manage your Kubernetes cluster on Amazon Cloud environment using the EKS distro distribution flavor of Linux OS. AWS Lambda. This AWS service allows you to run functions in the cloud. The tool is a big cost saver for you, as you to pay only when your functions execute. Amazon EC2 Spot. A Spot instance is an unused EC2 instance that is available for less than the on-demand price. Because Spot instances enable you to request unused EC2 instances at steep discounts, you can lower your Amazon EC2 costs significantly. The hourly price for a Spot instance is called a spot price. Spot instances are useful for stateless fault-tolerant or flexible applications, such as big data containerized workloads, CD web servers, high-performance computing, HPC, and test and development workloads. The Amazon EC2 Spot can automatically add or remove compute capacity to meet changes in demand. Amazon Light Sail. Amazon Light Sail is an easy-to-use cloud platform that offers you everything you need to build an application or website. It also provides pre-built template images to readily deploy application, like WordPress. AWS Batch. AWS Batch is a set of batch management capabilities that enables developers, scientists, and engineers to easily and efficiently run hundreds of thousands of batch computing jobs on AWS. It is a fully managed batch processing at any scale. Storage services. The AWS Storage Gateway is a hybrid storage service that enables our on-premises applications to seamlessly use AWS cloud storage. We can use the service for backup and archiving, disaster recovery, data processing, storage tiering, and migration. Database services. Databases play a vital role in the functioning of an application. Also, performance of an application is directly dependent on how the underlying database performs for the application. AWS Database Services is a set of database offered by AWS on the cloud. Relational database. In relational databases, the data is usually stored in a tabular format. Relational databases particularly use structured query language to run queries, to perform operations such as insertion, updating, deletion, and more. AWS provides following relational database services: Amazon RDS, Amazon Redshift, Amazon Aurora. Key Value Database. The key value database is a type of NoSQL database where the method of having a value attached to a key is used to store data, meaning that the data is composed of two elements, keys and values. Amazon DynamoDB. In-memory database. This type of database is primarily based on the main memory for computer data storage. Basically, an in-memory database keeps the whole data in the RAM, meaning that each time you access the data, you only access the main memory and not any disk. And the reason that the main memory is faster than any disk is why in-memory databases are so popular. Amazon Elastic Cache. Management tools. The management tools domain consists of services which are used to manage other services in AWS. It includes the services of Amazon CloudWatch, Amazon CloudFormation, and AWS CloudTrail. Admin can manage and track cloud resource configuration via AWS config rules. Those tools, along with AWS Trusted Advisor, can help an IT team avoid improperly configured and needlessly expensive cloud resource deployments. AWS provides several automation tools in its portfolio. An admin can automate infrastructure provisioning via AWS CloudFormation templates, and also use AWS OpsWorks and Chef to automate infrastructure and system configurations. An AWS customer can monitor resource and application health with Amazon CloudWatch and the AWS Personal Health Dashboard, as well as use AWS CloudTrail to retain user activity and API calls for auditing. Migration services. Migrations to AWS include moving any workload from an on-premises environment, hosting facility, or other public cloud. AWS is working with thousands of organizations to migrate workloads such as applications, websites, databases, storage, physical or virtual servers, or the entire data centers. Content Delivery Network Services. The networking and content delivery domain is used for isolating your network infrastructure. And content delivery is used for faster delivery of content. It includes the services of Route 53 and AWS CloudFront. AWS has the largest global infrastructure footprint of any provider. This allows the AWS global network to deliver customer applications and content anywhere in the world over a private network. This will help the company to be more secure. Amazon Route 53 is a highly available and scalable cloud domain name system (DNS) web service. It is designed to give developers and businesses an extremely reliable and cost-effective way to route end users to Internet applications by translating human-readable names, such as www.example.com, into the numeric IP addresses, such as 192.0.2.1, that computers use to connect to each other. Amazon Route 53 is fully compliant with it as well. Amazon CloudFront is a fast content delivery network, CDN, service that securely delivers data, videos, applications, and APIs to customers globally, with low latency, high transfer speeds, or within a developer-friendly environment. CloudFront is integrated with AWS dashboard physical locations that are directly connected to the AWS global infrastructure, as well as other AWS services. CloudFront works seamlessly with services including AWS Shield for DDoS mitigation, Amazon S3 Elastic Load Balancing, or Amazon EC2 as origins for your applications. And Lambda attached to run custom code closer to customers, users, and to customize the user experience. Security and Identity Compliance Services. The security and identity compliance domain consists of services which are used to manage, to authenticate, and provide security to your AWS resources. It consists of the following services: AWS IAM, AWS KMS, AWS Shield. Messaging services. AWS messaging services provide core communication for users and applications. Amazon Simple Queue Service, SQS, is a managed message queue that sends, stores, and receives messages between components of distributed applications to ensure that the parts of an application work as intended. Amazon Simple Notification Service, SNS, enables a business to send, publish, subscribe messages to endpoints, such as end users or services. SNS includes a mobile messaging feature that enables push messaging to mobile devices. Amazon Simple Email Service, SES, provides a platform for IT professionals and marketers to send and receive emails.
Wow, that was so informative. So many services at the same place.
That's not all. There are also some commonly used services which are also provided by AWS.
Tell me about them.
Sure. Let's go. Commonly used services provided by AWS are: compute, container, database, developer tools, networking and content delivery, security, identity, and compliance, serverless, storage, management and governance. Now, let's learn more about each service one by one. Compute. Amazon EC2. Virtual servers in the cloud. Amazon EC2 auto-scaling. Scale compute capacity to meet demand. Amazon Lightsail. Launch and manage virtual private servers. AWS Batch. Run batch jobs at any scale. AWS Elastic Beanstalk. Run and manage web apps. AWS Lambda. Run your code in response to events. Container. Amazon Elastic Container Service. Highly secure, reliable, and scalable way to run containers. Amazon Elastic Kubernetes Service. The most trusted way to run Kubernetes. AWS App2 Container. Containerize and migrate existing applications. Database. Amazon RDS. Managed Relational Database Service for MySQL, PostgreSQL, Oracle, SQL Server, and MariaDB. Amazon Aurora. High-performance managed relational database. Amazon DynamoDB. Managed NoSQL database. Developer tools. AWS Code Build. Build and test code. AWS Code Commit. Store code in private Git repositories. AWS Code Deploy. Automate code deployment. AWS Code Pipeline. Release software using continuous delivery. AWS Code Star. Develop and deploy AWS applications. AWS Command Line Interface. Unified tool to manage AWS services. Networking and content delivery. Amazon VPC. Isolated cloud resources. Amazon API Gateway. Build, deploy, and manage APIs. Amazon CloudFront. Global Content Delivery Network. Amazon Route 53. Scalable Domain Name System. AWS Private Link. Securely access services hosted on AWS. Security, identity and compliance. AWS Identity and Access Management. Securely manage access to services and resources. Amazon Cognito. Identity management for your apps. Amazon Detective. Investigate potential security issues. Amazon Guard Duty. Managed Threat Detection Service. AWS Certificate Manager. Provision, manage, and deploy SSL/TLS certificates. AWS Shield. DDoS protection. AWS Single Sign-On. Cloud Single Sign-On, SSO, service. AWS Wave. Filter malicious web traffic. Serverless. AWS Lambda. Run code without thinking about servers. Amazon DynamoDB. Managed NoSQL database. Amazon Simple Notification Service, SNS. Pub, sub, SMS, email, and mobile push notifications. Amazon Simple Queue Service, SQS. Managed message queues. Amazon Simple Storage Service, S3. Scalable storage in the cloud. Storage. Amazon Simple Storage Service, S3. Scalable storage in the cloud. Amazon Elastic Block Store, EBS. EC2 block storage volumes. Amazon Elastic File System, EFS. Fully managed file system for EC2. Cloud Endure Disaster Recovery. Highly automated disaster recovery. Management and governance. Amazon Cloud Watch. Monitor resources and applications. AWS Auto Scaling. Scale multiple resources to meet demand. AWS Compute Optimizer. Identified optimal AWS compute resources. AWS License Manager. Track, manage, and control licenses. AWS Managed Services. Infrastructure Operations Management for AWS. AWS Ops Works. Automate operations with Chef and Puppet.
So many services. I kind of not sure how these services fit into any business use case.
I know. Let me walk you through a business use case. Let's understand practical use case for using various AWS services in a typical web application. Let's assume that we are going to build our social media platform, myfb.com. So, what all components would be there in our architecture? First thing you will need is one private network, like every company has their own private network. We would also require something like this to make it secure. Of course, the next thing you would require is a web service now, to start with. Suppose we are a startup. Then, we will probably build a small code in maybe PHP, and we will run in some kind of application server, or on web server, and it should work maybe for at least 200 users, or lower than that, and it works fine. And our users will access this application using IP address initially. So, maybe this VM has some public IP, and users access it. Now, what happens over the time is like, you want to now extend your application, and you want to add some business logic, some UI stuff, the login functionality, and more. So, that's where you need to then have a web server as well as application server, so that all the front-end stuff is taken care by web server. But, all business logic. Suppose it's a Facebook kind of application, then maybe they are. You connect with different people. So, adding the data, and everything is taken care of by application server. And of course, further if you want to extend it, you need some kind of database like relational database, MySQL, and even you can have Oracle, whatever you prefer, right? So, if you have this kind of application, it works well. It's called three-tier architecture, and your users are using this application, using an IP address, right? So, this works well. And considering the app is really doing good, your website is really doing good, and there is more traction from the users, and somewhere then your web servers, or an application server's bottom, becomes bottleneck. Maybe they are not able to handle the increased load on your application. So, what's the solution? Typically, we will scale now. That scaling can happen, vertical scaling. That means, you increase the capacity of these machines, or, you could do horizontal scaling. So typically, in 3-tier architecture, you will see web servers, and application servers are scaled horizontally. That means, you will bring more web servers, and more application servers, right? Like, I have shown here. Okay, that's fine. Now, I have multiple web servers, and multiple application servers. But as you know, there are multiple web server. That means, there are multiple IP addresses, and now is the time, where we need an intelligent entity, who can really distribute load to this web service. And that's where, we bring in the load balancer service. So, if you heard about a load balancer like a cheap proxy, and Engine Incorporated, they do something like this. A user hits the request to the load balancer, then evenly distribute that to a backend servers like this, and as you know, now we have load balancers also, and your application is really catching up. Typically, you don't want your application to be accessed using IP address. You want people to access your application with the domain name, something called say a bitcom, and that's where you need some DNS service, where you can map your DNS, this domain name to load balancer, probably write a KSO, so far so good. This works fine, right? Your application is 3-tier, and it is working well. Now, it catches a further, and you are now having a lot of data, or say you have number of friends, or growing number of connections, or growing number of posts are growing, and that's where your relational database can really solve this kind of, maybe data storing data. You cannot do that in relational databases. For this, you need a scale of a database, and also for connection information and all. It makes sense to rather going for NoSQL databases. So, what you will do? Bring in the NoSQL database, like MongoDB, or Cassandra. Anything that you want to assert, some part of data is stored in relational databases, and other is storing non-relational, or NoSQL databases, but still your relational databases could be outperformed and spots, or, Nick, maybe there is a very real heavy operations happening on this database, and for that, typically you will bring in one more component, which is called database caches. Okay, so you bring in some database cache engines, like Redis Market, where you can query either frequently accessed data, so that your application servers don't hit the database, but all the requests are served from this cache engine. Service is fairly better architecture, what we saw where we started with now. Next thing, as you know, Facebook might be getting millions of pictures and videos uploaded daily. Now this quick chart attached to the VM are not really capable of extending on the fly. They have size limitations, and that's where all these media pictures are never stored. Typically, on this web servers, or an application service, for this you need some unlimited kind of storage, and that's an external storage. And it should not be necessarily block storage, like your artist could be a file storage, like a share file system, or some external storage like Google Drive, if you are aware of, right. So, you need some external storage, where you store this information. Okay, so that makes your storage. That solves you a storage capacity problem. If you use external storage, that's fine. So far, so good. Now, next what happens is, when you are upload the videos or photos, you need some kind of content filters, like maybe you are uploading videos. In that video is some comments which are objectable, or there are some pictures we have which has some nudity. So you need some content filer which can do this on the fly. And then most pictures we do should be actually stored here in the external storage. So we bring in one more component, their rights. Okay. It's fine now. You also know Facebook call, so throws a lot of ads zoned. It is continuously watching what activities you are doing while you are on the Facebook page. Maybe what kind of products you are liking, what kind of posts you are liking. And based on that, it gives you suggestions. And the friend request will throw a lot of ads. Right. So this is called click-stream analysis. Every click is getting captured somewhere, and it is getting analyzed in real time. So you need some kind of click-stream analysis engine there. Right. Let us take an example. Twitter. What all tweets are going on in the market? What is the mood of the people currently? All this system using the click-stream analysis on Facebook also. You have something like this. Now all the states are watching this click-stream analysis engine captures. It has to store somewhere in the external storage. Right. And you need an external storage for this, like this storage for storing this data and further. You want to take this state and do some data operations like you need to run some. Maybe aggregations. You need to sort your data and due to find some mainly out of the date. And that's where you need some kind of audio platform which can perform the computing on distributed systems. Right. So you need some kind of a Hadoop platform, and you would also require over the time data warehousing. Why? Because maybe at the end of the year, or Facebook does a lot of data analytics strike. Maybe at the end of the year, they want to find out which kind of users are accessing Facebook more. What are their age limit, in which region they come from, the particular feature of Facebook they are watching, so that they can concentrate more on those kind of features. What is trending? All this information is taken out by storing this information in some kind of warehousing engine and doing some kind of business in elections on top of it. So you need some business inter-election which can query. They stay to analyze this state, and then there are reports generated, out of which then Facebook can take decisions like next year. Maybe this is our strategy, and we will focus on this area or that area. So some business decision you can drive based on what analytics results come out of this. Okay, so this is all about. This is more on a backend in size, which end give us clearly. No, but this is happening there. Okay, so far, so good. So we have extended our architecture now. Next, what we have is all these photos and videos. They can be directly served over the internet because you can sit off. This is like a Google Drive. So you can directly maybe stream your videos and watching pictures directly from this storage. So users might come from the web browser, and they may watch whatever post. Suppose you have posted a video, so they can watch the video here. But sometimes your users come from using mobile devices. Nowadays, they will watch your videos through mobile, and in that case, you need the same videos, but probably in different format. That's because mobile device might play a different format of the video. And for this, typically we will need some kind of video converter in between. So whenever any users upload some videos, maybe they should be immediately converted into a mobile-friendly format. All right. So you need some kind of computing hardware as well. Okay. So we will introduce. That's why a video converted here next to all these photos and videos are typically served from, as I said, from the external storage. But you know, whenever some video gets viral, right, millions of users watch the video. Now every time. If that video is fetched from this location, this might become a bottleneck, or you may pay a price, because your data is flowing out to the internet, and there are a lot of usage of your videos, so forth. To solve this problem, you need to have something called CDN, Content Delivery Network. which is nothing but dot, which caches these videos and pictures to the nearest caching devices from whether user is accessing your videos. Right. So that's all. The users in geography, when they want to watch the same video, it is served from here. It is not really served from here. So user experience, the low North Carolina better experience. So in applications like Instagram and Facebook, Twitter and YouTube largely, they would have a lot of content delivery networks through which the contents are served. Which the contents are solved. Okay, so far so good. We have extended architecture further. Now, you know, Facebook also sends your mobile notifications, right? There is a new friend request, or there is a likes on your post. Now for this, we need some kind of notification service, right? Maybe you get an SMS, or mobile push notifications. So, you need that service also. It sends you emails, right? For various activities you can disable that, but there is options to offer email services. Well, right? And further, you can also chat with your friends, and for this, typically a queue's used no messaging queue. If you heard about like RabbitMQ, Gemma's queues, IBM MQ, on queue services, which enables the kind of first in first out, and the kind of data structure. So, for chatting maybe you require some kind of queue service as well. Okay, so, if we consider all these services, it's a bare minimum kind of social media application. I'm sure there must be many more components, but we are just sticking to this, as of now. And, finally, if you want to deploy this architecture, and monitor it continuously, like how my VMs are doing, how my databases are doing, and how my storage is doing, how much storage is there. All this, you need some kind of monitoring service, and the dashboards. Like production dashboard, where you can monitor health of your application. Okay, so, overall this will be your architecture, and this probably be deployed on premises, and now let's see, if you want to do the same thing on AWS, then, how we will do this, we want to do this now, on AWS. So, let's see first thing this private network, what you see here in AWS world, it is called VPC, Virtual Private Cloud. So, it is not exactly the way it is shown here. Because some of these services are outside VPC, but I cannot accommodate that in a diagram. But consider VPC has one private isolated network that AWS gives you, and then you would have to manage all the public URL network for web servers, and load balancer, and a private network for databases that is a separate part of discussion. But the VPC is a network service. Now, all these VMs that we are talking about, these are nothing but Act 2 machines, right? And the disk that we attached, it's called DBS Elastic Block Storage, and they have limitation of maximum size. So, easy to an AWS solves your problem of the VMs that typically will deploy your applications on whether web servers or app servers. Now, further you can have an auto-scaling enabled for RSI tools. That means, if the load increases on this too, they can scale horizontally, automatically, and, if the load decreases, they can scale down, maybe, from 2 machines, they can go 10 machines, from 10, they can come back to 2 machines, depending on the load, that you can configure, using auto-scaling feature of AWS, Act to further for databases, relational databases. There is a service called RDS, and for NoSQL databases. There is a service called DynamoDB, for Decibel Cache. There is a service called Elastic Cache Service, and it comes with a Redis, and Memcached the engines in that. Okay, further as you see there is a load balancer, so, in Amazon, there is a service called ELB, Elastic Load Balancer Service, which can distribute the incoming traffic to multiple backend 2 machines, like this, and for that, if you want to have your domain name mapping to your load balance, and then you need a DNS service, which is called Route 53. Okay, great. Now, let's talk about the other stuff that we have like for external storage. It is an S3 service of Amazon, simple storage service. Right. Which is unlimited storage. You can just go on dumping the data, and it is accessible over the internet directly, and there is no size limitation, how much data you can store in your S3 buckets. Also you need some content filter. So, there is a service called Recognition, which can find out inobjectable images, and it can filter it out before you upload it to the say S3 buckets. Okay, now as I said, you need some kind of service where your videos from one format get converted to another format, like MP4 to some mobile-friendly format. Now for this, one option island, you run submit to machines, which continuously watch your S3 buckets for new videos. As the new video comes, they download it here, convert it, and put it back into another bucket. That is one option, but there is a better option for this, like Lambda service. No, Lambda is service of Amazon, where you just try to code in that code, you specify how to maybe convert a video, and you can execute this Lambda function whenever there is a new upload happening into your S3. So, new video comes, Lambda to gets triggered, it will convert your video, and maybe you have put in logic that put that video into another S3 bucket zone. Now here, there are no servers to manage, everything is taken care by Lambda functions, and this scale automatically. Okay, so, we got Lambda there. Now, let's talk about this, clickstream analysis. Now, for clickstream analysis, there is a service called Kindnesses, which can captures your clickstream data, and then, you can analyze that data, you can even further, store that data in S3 and can do much more with whatever data you captured right now. For this, Park-R Hadoop platform, there is a service called EMR, and for EMR those who like operations, like aggregations, sorting, and you can run distributed jobs, Spark jobs, filling jobs, all this you can run in this managed Hadoop cluster, and you also need to do ETL transactions from your DynamoDB tables, like, maybe you want to do, what all friends are their friends, what activities they are doing. That, you want to continuously push a new post on your wall. Now, all this is done in real time, using clickstream analysis, and, at the end of the year, maybe, you want all this data to be extracted, converted into different formats, data cataloging, and then, further do some data processing, using EMR. So, you need this glue service for doing this, extract, transfer, transform, and load operations, ETL operations. Right. And then finally, all this data what you process, or what data you have. You can store it in the data warehouse service, which is nothing but Redshift in Amazon. So, Redshift is a data warehousing service, which can store petabytes scale of data, and you can perform the analysis on the data, and, to perform this analysis, and, see the results, you need some BI tools, which there are various BI tools in the market, but, in Amazon, you will use Amazon QuickSight, or, you can also use SQL Query Interface. So, you can pull data from S3 platform, maybe, in the SQL operation on that, and, all those results can be viewed in a QuickSight. You build some graphs, some charts, and, you get insights of your data, based on that. You will take some business decisions. So, it's a BI service from Amazon. Okay, so far, so good. We introduced lot of AWS services here. Now, as I said, there is a content delivery network, which can cache your static content, and, for this, in Amazon, there is something called CloudFront Service, and CloudFront Tools, or cache. Is your data in edge locations? Like I said, their edge locations are there, in cities, across 100 plus cities, across the world. And when you use CloudFront Service, all your data from S3, or whether your story, or data, it gets cached in the nearest edge location, from where the user is coming in. The data is always served from that edge location, for all the users, in that geography. Okay, so, that's a CloudFront service. Also, as I said, you need to send messages, and mobile push notification in Amazon. There is a service called SNS, Simple Notification Service. And, if you want to send emails, a bulk email, then, there is service called SES, Simple Email Service. Now, for messaging queues, for chatting application, Amazon has built its own queue service, which is called SQS, Simple Queue Service. And finally, to monitor all this infrastructure, how may I see tools are doing, was the CPU utilization of VC tools. How is databases doing? All these can be monitored in real time, using a service called CloudWatch. Even, you can set alarms, like, if an average SIP utilization goes beyond, say this person send an email, or order to administrator, or take some action, do some watch scaling here. All this can be done, using this CloudWatch alarm there. Okay. So, I think, we have completely replaced what we did on premises, with AWS services, and I hope you've got some idea about all these basic AWS services. AWS free tier. To have a feel of various cloud services offered, AWS provides free tier usage, unlimited services. Users can register with AWS as service consumer with required details and avail the free tier services. The services are categorized into 3. Number 1. Always free services. These free tier offers do not expire and are available to all AWS customers. Number 2. 12-month free services. Enjoy these offers for 12 months following your initial sign-up date to AWS. Number 3. Trail services. Short-term free trial offers start from the date you activate a particular service. The 6 pillars of the AWS well-architected framework. When building technology solutions on Amazon Web Services, AWS, if you neglect the 6 pillars of operational excellence, security, reliability, performance efficiency, cost optimization, and sustainability, it can become challenging to build a system that delivers on your expectations and requirements. Incorporating these pillars into your architecture helps produce stable and efficient systems. Let us learn more about each pillar, one by one. AWS Architecture Pillar, Operational Excellence. The Operational Excellence pillar includes the ability to support, development, and run workloads effectively, gain insight into their operation, and continuously improve supporting processes and procedures to deliver business value. There are 5 design principles for operational excellence in the cloud. Perform operations as code. Make frequent, small, reversible changes. Refine operations procedures frequently. Anticipate failure. Learn from all operational failures. Operations teams need to understand their business and customer needs so they can support business outcomes. AWS Architecture Pillar, Security. The security pillar includes the ability to protect data, systems, and assets, to take advantage of cloud technologies, to improve your security. There are 7 design principles for security in the cloud. Implement a strong identity foundation. Enable traceability. Apply security at all layers. Automate security best practices. Protect data in transit and at rest. Keep people away from data. Prepare for security events. You want to be able to identify security incidents, protect your systems and services, and maintain the confidentiality and integrity of data through data protection. You should have a well-defined and practiced process for responding to security incidents. AWS Architecture Pillar, Reliability. The reliability pillar encompasses the ability of a workload to perform its intended function correctly and consistently when it's expected to. This includes the ability to operate and test the workload through its total life cycle. There are 5 design principles for reliability in the cloud. Automatically recover from failure. Test recovery procedures. Scale horizontally to increase aggregate workload availability. Stop guessing capacity. Manage change in automation. A reliable workload starts with upfront design decisions for both software and infrastructure. For reliability, there are specific patterns you must follow, such as loosely coupled dependencies, graceful degradation, and limiting retries. Regardless of your cloud provider, there is the potential for failures to impact your workload. You must, therefore, take steps to implement resiliency in your workload, such as fault isolation, automated failover to healthy resources, and a disaster recovery strategy. AWS Architecture Pillar, Performance Efficiency. The performance efficiency pillar includes the ability to use computing resources efficiently to meet system requirements and to maintain that efficiency as demand changes and technologies evolve. There are 5 design principles for performance efficiency in the cloud. Democratize advanced technologies. Go global in minutes. Use serverless architectures. Experiment more often. Consider mechanical sympathy. Monitoring ensures you are aware of any deviance from expected performance. Make trade-offs in your architecture to improve performance, such as using compression or caching or relaxing consistency requirements. The optimal solution for a particular workload, varies, and solutions often combine multiple approaches. AWS well-architected workloads use multiple solutions and enable different features to improve performance. AWS Architecture Pillar, Cost Optimization. The cost optimization pillar includes the ability to run systems to deliver business value at the lowest price point. There are 5 design principles for cost optimization in the cloud. Implement cloud financial management. Adopt a consumption model. Measure overall efficiency. Stop spending money on undifferentiated heavy lifting. Analyze and attribute expenditure. Design decisions are sometimes directed by haste rather than data, and, as the temptation always exists, to overcompensate rather than spend time benchmarking for the most cost-optimal deployment. This might lead to over-provisioned and under-optimized deployments. Using the appropriate services, resources, and configurations for your workloads is key to cost savings. AWS Architecture Pillar, Sustainability. The discipline of sustainability addresses the long-term environmental, economic, and societal impact of your business activities. There are 6 design principles for sustainability in the cloud. Understand your impact. Establish sustainability goals. Maximize utilization. Anticipate and adopt new, more efficient hardware and software offerings. Use managed services. Reduce the downstream impact of your cloud workloads. Choose AWS regions where you will implement workloads based on your business requirements and sustainability goals. User behavior patterns can help you identify improvements to meet sustainability goals. For example, scale infrastructure down when not needed. Position resources to limit the network required for users to consume them, and remove unused assets. Implement software and architecture patterns to perform load smoothing and maintain consistent high utilization of deployed resources. Understand the performance of your workload components and optimize the components that consume the most resources. Summary. Through this module, you have learned that Amazon Web Service is a platform that offers flexible, reliable, scalable, easy-to-use, and cost-effective cloud computing solutions. Services are there, but they are grouped under separate features like compute, security management tools, storage, messaging, database migration, networking, analytics, and some commonly used services.
Thank you for taking this module.